Hello students, I am Dr. S.M. Bhatti. The objective of this video is to find Fourier transforms of some functions. As seen in last video, there are three types of transforms. One is a Fourier transform, second is Fourier cosine transform, third is Fourier sine transforms. And these transforms are denoted by capital F lambda, capital Fc lambda and capital Fs lambda respectively. And to find them, we have to use respective formulas. Sometimes we may given the value of capital F lambda, capital Fc lambda or capital Fs lambda. In that case, we may require to find their respective inverse transforms. In that case, we have to use these three equations respectively. And here we can get the value of f of x. This f of x actually stands for inverse Fourier transform capital F lambda, while this f of x stands for inverse Fourier cosine transform of capital Fs capital Fc lambda, while this f of x stands for inverse Fourier sine transform of capital Fs lambda. So these are the six formulas, and we have to make use of the formulas effectively as per our requirement. Let's see this in an actual example. Already we have solved one example in our last video. Let's take now second example. Find Fourier sine transform of 1 upon x. Now Fourier sine transform of the function f of x is capital Fs lambda, and it is given by the equation 3a, and this is equation 3a. Capital Fs lambda is equal to integration from 0 to infinity f of u sine lambda u du. Now we have to call this function 1 upon x as f of x. That means we must write f of x equal 1 upon x. But look at the equation 3a in right hand side. We have f of u. So we have to write f of u. But we know the f of x. So from f of x we can get f of u by replacing x by u. That means f of u became 1 upon u. And we have to make substitution of this f of u in the right hand side of this equation 3a. We can get this. Now to simplify this integral, to evaluate this integral, we have to make a substitution. We have to put this lambda u as a t. That means we are converting variable u to t, because for this integral lambda is a constant and u is a variable of integration. So when we put lambda u as a t, that means we are converting variable u to t. The status of lambda is a constant. Hence, by taking differential on both sides, we can say that lambda into du is equal to dt, from which we can get du is dt upon lambda. Also, if you observe this integral, it has a limit 0 to infinity, and these are limit for u. That means u has a limit 0 to infinity. Now this equation join u and t. So when u is 0, from this first equation t also became 0, and when u is infinity, t also became infinity. That means limit of t also 0 to infinity. Limit of u were 0 to infinity. Now new variable t also has same limit 0 to infinity. Now convert this right hand side in new variable t along with the limit. That's why Fs lambda is now equal to integration from 0 to infinity. These are limit for t, and here limit of t remains same. Then 1 upon u. So from this equation 1 upon u is nothing but lambda upon t. Then the value of lambda u is a t, while value of du is dt upon lambda. You can see that in next step lambda will get cancelled, and you will find integration from 0 to infinity sin t upon t dt, and the right hand side is a standard integral and it has a value pi upon 2. So in this way we obtain the value of fs lambda as a constant pi upon 2. Let's take now example 3. Find the Fourier cosine transform of e raised to minus x plus e raised to minus 2x, x greater than 0. Note that x greater than 0, that means x is a positive, but it is non-zero. That means x is between 0 to infinity, right? So we can take this function as f of x. Hence, in a solution, we can write the first line as f of x is equal to this function with limit 0 less than x less than infinity. That is, interval for this function is 0 less than x less than infinity. Now we replace x by u. When replace x by u, you can get next step. It is f of u is equal to e raised to minus u plus e raised to minus 2u comma 0 less than u less than infinity. Remember, we have to find Fourier cosine transform, and the Fourier cosine transform of the function f of x is capital Epsilon lambda, and it is given by equation 2a, and it is capital Epsilon lambda is equal to integration from 0 to infinity f of u sin lambda u du. Right? Now, in this equation, we have to put the value of f of u. And just above, we obtain the value of f of u. So, we substitute the value of f of u because f of u contains two terms. So, we must write these two terms in the bracket. Then in next step, we multiply this bracket by cos lambda u so that you will find e raised to, in the bracket you will find e raised to minus u cos lambda u plus e raised to minus 2u cos lambda u du. In next step, we can split this integral in two terms. You can see that in next step, we have split this integration in two terms. The first term is 0 to infinity e raised to minus u cos lambda u du plus this plus sign is continued here, integration 0 to infinity e raised to minus 2u cos lambda u du. You can see that here the limits 0 to infinity remain same for the both terms. Now we want to evaluate these two integral in the right hand side. So we have to understand the type of these two integral. Fine. You can see that the right hand side, this is right hand side. The right hand side has a type integration from alpha to beta e raised to minus au cos bu du. And so we have to make use of this formula, that is integration from alpha to beta e raised to au cos bu du is equal to in the bracket e raised to au upon a square plus b square in the square bracket a cos bu plus b sin bu from limits u equal to alpha to u equal to beta. Fine. Now for the first term, you can see this is the first term, and first term is an integral which are this type, and when you compare you can get the value of alpha and beta. Easily you will find alpha is 0, beta is infinity, and a is here minus 1 for the first term, while b is a lambda. You can see in second term also has same type. The difference is value of a. In second term the value of a is minus 2, and note that e raised to minus infinity is 0. So you have to apply this formula for the first term, also for the second term. First term, second term, both have same type. You can see that here alpha is 0, beta is infinity. Difference is a. A is here minus 1, while here a is minus 2. B is the same. B is a lambda for the both terms. So we will apply these two formula, and when you apply this formula in both terms, you will get the second term, and you can see that next step. You can see next step as a capital Epsilon lambda e raised to au, that is e raised to minus u upon a square plus b square, that is 1 plus lambda square. In the bracket, a cos bu plus b sin bu, that is minus 1 cos lambda u plus lambda sin lambda u with limit 0 to infinity. Limits are for the variable u. Similarly, for second term, e raised to au, that is e raised to minus 2u upon a square plus b square, that is minus 2 whole square plus lambda square into minus into, here is a, so a is minus 2, a cos b bu, that is cos lambda u plus b, that is lambda sin bu, that is sin lambda u, and limit are 0 to infinity. First we put u is infinity here. When you put u is infinity, you will find e raised to minus infinity, and as I said you that e raised to minus infinity is 0, so that becomes 0. Then you put u is 0. When you put u is 0 here, e raised to minus 0, that is 1. Denominator is same, 1 plus lambda square, and here you will find minus cos u plus sin u. You know cos 0 is 1, sin 0 is 0, so you will find here minus 1 plus. Similarly, for the second term, you will find 0 minus 1 upon 4 plus lambda square into minus 2. And simplifying and after making the cross multiplication, easily you can find the value of epsilon lambda. If you look at the right hand side contains function of lambda that justified with the left hand side notation, that is epsilon lambda. So in this way we obtain Fourier cosine transform of the given function. Now here is a fourth example. Find Fourier cosine transform of the function f of x which has the two values. One is cos x when x is between 0 and a, and second value is 0 when x is a greater than a. Fine. Now solution. Fourier cosine transform of the function f of x is epsilon lambda, and which is given by the formula, that is by 2a epsilon lambda is equal to integration from 0 to infinity f of u cos lambda u du. Fine. Now in this formula the right hand side contains f of u, but we know f of x. So from f of x we have to write down f of u. And how to write down f of u here? By replacing x by u. Hence f of u became a function. F of u is equal to two values. One is a cos u when u is between 0 and a, and another value is 0 when u is between a and infinity. Note that this 0 don't have meaning, so I should cancel this 0. Okay, fine. I will do it, don't worry. Even for the now you can see that I have corrected this 0, and now here we have to split this integration in two parts. Here we have an integration from 0 to infinity, but if you look at the intervals here, 0 to a, then a to infinity, so we split the integration in two parts, 0 to a and second is a to infinity. In the interval 0 to a, the f of u has a value cos u, so here we will take this f of u as a cos u, while in second term if that is when the range is when limits are a to infinity, value 0, so here we have to consider. You can see that second term is directly become 0. In first term we have multiplied by 2 and divided by 2 because we want to make this integration simple. Now here you apply the formula 2 cos a cos b. The role of a is played by u and role of b is played by lambda u. You know formula 2 cos a cos b is cos of a plus b plus cos of a minus b. So we have used this formula. Further we take u common between these two terms. Also we can take u common from these two terms. When we take u common, you can get this. Now the integration became very simple. Integration of this cos lambda plus 1 u is sin lambda plus 1 u upon lambda plus 1, because lambda is constant here. While for integration of second term, integration of cos of lambda minus 1 u is sin lambda minus 1 of u upon lambda minus 1 with limit for u are u is 0 to u is a. When you put u is a, you can get this yellow part, then minus sign. When we put u is 0, you can get this green part, and you know sine 0 is 0, so the last two terms became a 0, and in this way we can get Fourier cosine transform of the given function. For making this video, we have used these two references. In this way, today we have obtained today we have obtained Fourier transform of sum of the function. Thank you very much.